Hi guys, welcome to our first lesson on the mole. So this is actually content that we covered at the very end of last term, but because of all the drama that was sort of going on, I wasn't quite sure if everyone was comfortable or if everyone was on the same page. So I thought we should start off the term by doing a little bit of a refresh on previous content. The other reason that I wanted to start off with a nice simple video is because I want you guys to get familiar with the layouts of these videos or how these videos are going to work. So as I mentioned in my previous video, I'm actually going to pop these OneNotes once I finish them up onto our eLearn, and then you guys can just access it from there. So with our weekly check-in, what you actually are required to do as part of that weekly check-in is to take your learning goals for the week. So what I would suggest doing, once this OneNote is uploaded, I would suggest just copying and pasting each of these learning goals for week 1 into a separate Word document, and then it's going to be a lot easier for you to submit that with your weekly check-in. You don't have to submit the success criteria, but one of the text things that you have to fill out is, it was asking about activities that have demonstrated how you've met that particular learning goal. So our success criteria is actually the activities or the types of things that we're going to be doing to meet that particular learning goal. So if you're looking for ideas when you're filling in that weekly summary, what I would actually do is I would just copy and paste the success criteria in, as well as like listing any other activities that you've done for the week. The last little thing I've got up here is the vocabulary or the word list. And what I want you to do is I want you to find a separate spot, so maybe in the back of your book or maybe on a Word document, and I want you to start collecting some words, because when you guys go back to do your revision, if all the key terms are already there in one spot, it's going to be a lot easier for you to do that revision. Just like I do in class, I've also got the key ideas from each chapter. So let's jump in. Let's talk about what we're actually going to be doing today. So we're looking at or reviewing Avogadro's constant. So we know that atoms and molecules are quite small, and it's really difficult for us to, try and weigh or try and find like one particular atom and put one atom on a scale, and for that scale to actually register the weight of that atom, right? They're so small, it's really, really difficult for us to actually do that individually. So instead what we do is we sort of get clumps of them, right? And we call these clumps moles. So in 1 mole, there is an exact number of particles. And what we tried to do, or I shouldn't say we, what scientists have tried to do previously is they've gotten the number that's on the periodic table, so their relative atomic mass, and they've said, okay, I want to figure out what mass in grams of that substance is going to be equal to that same number on the periodic table. How many atoms must be present for that to be true? And they've actually worked out that number to be this constant, Avogadro's constant. So if I was to look on the periodic table, for example, looking at hydrogen, so the atomic mass of hydrogen is 1.01, right? So they said, okay, so if I was to get a particular number of particles, and I want that particular number of particles to weigh exactly 1.01 grams, how many particles would there be? And they did some calculations based on electrons and charges and stuff like that. And what they actually worked out was they worked out this value of 6.02 times 10 to the power of 23. Okay, so 1 mole contains 6.02 times 10 to the 23 items. So that could be, molecules, or it could be individual atoms. But it's that special number, 6.02 times 10 to the 23. So for example, if I had a mole of cars, 1 mole of cars would contain 6.02 times 10 to the 23 cars. 1 mole of oxygen gas contains 6.02 times 10 to the 23 molecules of oxygen, right? If I was talking about the individual atoms of oxygen, we can see that the formula for this is O2. So if we double that, there's actually 1.2 times 10 to the 24 individual atoms of oxygen within 1 mole of oxygen gas. So I've got a few questions here, and these are just from page 171 in your textbook, and I'm going to go through the answers for these with you. So if you want to attempt them yourself, please pause the video now. But I'm just going to go through a couple of the trickier sorts of questions. I don't really need to go through question 1. We just sort of covered that. So a mole is just a particular amount of a substance, 6.02 times 10 to the 23 items in 1 mole specifically. Identify how many atoms are in 12 grams of carbon-12. Again, because we're trying to assume that 1 mole is the exact relative atomic mass as it is its weight, I'm going to assume there's 1 mole of 12 carbon because the mass of 12 carbon is exactly 12 AMU. All right, so let's go through these trickier ones now. So question 3, what I'm going to do for question 3, I'm not going to go through all of them. I'm just going to go through 3B and 3D. So 3B, determine the number of hydrogen atoms in 1 mole of H2 gas. Now, just like before, there's actually 2 atoms within 1 molecule of hydrogen gas. So I know that if it was 1 mole, it would have 6.02 times 10 to the 23 atoms, right? But we don't have H1 here, we've got H2. So I'm going to double that, and that's going to give me my answer for 3B, which is going to be 1.204 times 10 to the 24 atoms, okay? Now let's do the same thing. I'm going to do 3D as my second example. So in 3.5 moles of H2O. Now again, normally we have 6.02 times 10 to the 23 particles in 1 mole of a molecule, but we're not talking about the molecule, we're actually breaking it down into the individual atoms. So again, we've got 2 hydrogens, so I'm going to multiply that by 2. And instead of having 1 mole of hydrogen gas, I've now got 3.5 moles of water. So then, because I've got 3.5 moles, I'm going to multiply that by 3.5. And that's going to give me the total number of particles, which is 4.214 times by 10 to the 24 atoms. Oops. Excuse me. All right. So if you're still having difficulties this is the point where you would go into that section, oh gosh, I can't remember what it's called off the top of my head, but it's like if you're still having challenges or there are still questions in the textbook that you're having difficulty with, if you're still having issues with these, I want you to take note of that and I want you to put that into that weekly summary. All right, so let's have a go at question 4. So again, if you want to have a go at this yourself, be my guest. I'm only going to go through the answers for 4B just so that you guys can see the process. All right, so let's start off 4B. So first things first, let's read this question. In 1 mole, so let's write that, there's 1 mole of CH3COOH, determine how many molecules there are of hydrogen. Okay, so I'm going to assume that they mean individual atoms of hydrogen. So in each one of these molecules, there are 4 individual hydrogen atoms, okay? So now let's work out how many exactly that is. So if I've got 6.02 times by 10 to the 23 particles in 1 mole, and I've got 4 individual atoms, I'm just going to multiply that by 4, and that's going to give me 2.408 times by 10 to the 24 atoms of hydrogen. Now, for the other ones, you would do the same thing. With this one, carbon, you can see that there's only 1, so that's really easy. There's going to be 6.02 times 10 to the 23 individual atoms of carbon. And then there's 2. I lied, so there's going to be double that. And then same thing with the oxygen. We can see that in 1 molecule of this, there are 2 individual atoms of oxygen. So have a go, have a look at the answer in your textbook. And again, if you're still having issues with this, please put that in that weekly check-in or that weekly summary. All right, guys, so that's just my first little lesson on the mole, as well as some additional information about that weekly check-in and that weekly summary. I won't be talking so much about that in the next couple of videos. I'm just going to be jumping straight into the content and doing some questions. All right, talk to you guys soon. Bye.